Make sure to watch the main video on Mathologer before you watch this one. I promised you a proof that the strange clone of the real numbers that I construct at the end of the main video has measure 0. The zero measure property of our clone has got to do with the truncations of our clone numbers being incredibly good approximations. To understand what I mean by this, imagine that your friend picks an arbitrary number, truncates it after the second digit, and shows this truncation to you. Without knowing the original number, you can only be sure that this number is within 0.1 of this truncation. On the other hand, if your friend tells you that he started with one of our clone numbers, truncating after the second digit is the same as truncating after the fifth digit. This means that you can be sure that the original number is within 0.0001 of the truncation. Let's use this insight to show that all the clone numbers with a leading 0 are of measure 0. This set of numbers is a clone of the uncountably infinite set of all real numbers in the interval from 0 to 1. The little strokes mark the 100 possible truncations after the second decimal. For example, here is 0.11. The one next to it is 0.12, etc. Now, from what we just said, it is clear that every clone number is within 0.00001 of one of these 100 possible truncations. This means we can place 100 little intervals of this length on the number line that will contain all our clone numbers. This means that the set of clone numbers in this interval has lengths or measure less than the combined lengths of all these 100 intervals. This combined length is, well, 100 times the length, which is equal to 0.001. Now, if instead of going for the truncations after the 2 factorials digit, we go for truncations after 3 factorials, that is the 6th digit, this calculation changes to this one here. And this tells us that the measure is less than this tiny number at the bottom. Truncating further and further along gives estimates for the measure that approach 0. And therefore we can conclude that the set of clones in this interval has in fact measure 0. Now, as I already said in the last video, all these measure 0 considerations are made rigorous in a branch of mathematics called measure theory, which forms the foundations for things like integration. The fact that the truncations of our clones are an infinite sequence of ever more amazing rational approximations forms the core of Liouville's original proof that these numbers are transcendental. In fact, a lot of the more demanding transcendence irrationality proofs of numbers hinge on the somewhat surprising fact that it is much harder to find great non-trivial rational approximations of algebraic numbers than it is to find great rational approximations for certain transcendental numbers. Now, I already touched upon this in the video on the most irrational number, but a lot more remains to be said here. Okay, if I ever get around to making another video about this circle of ideas, here's my design for the t-shirt that I'll be wearing. Anyway, that's all for today.